Take one orange, cut it into a few pieces, then simply rotate them, move them and put them back together. And what you get is an orange exactly the same size as the original, not one but two of them. 9 times out of 10 you would call that person a fraud or a magician. After all, the volume has to stay the same. In 1924, the Polish mathematicians Stefan Banach and Alfred Tarski went ahead and proved that it can be done, at least in the world of mathematics. A solid ball can be cut into finitely many pieces and reassembled into 2 balls identical to the original. How many pieces does it take? 5 are enough. It has a proof, so it is a theorem. It is impossible to believe, so it is a paradox. There are no terrifying equations ahead. All you need is imagination plus 1 hotel, 1 dictionary and 1 tree. That last one, the tree, looks like this. It is a fractal grown out of 4 rotations. By the time we reach the end, you will be able to answer for yourself where on earth that volume came from. Before we get to the main story, let's clear away a look-alike fake. You have probably seen the infinite chocolate video floating around the internet at least once. You cut the chocolate bar along a diagonal, swap a few pieces around, and 1 square is left over. It is a trick, of course. The reassembled bar is very slightly smaller than the original one. Gather up the area of every thin strip that vanished, and it comes to exactly that 1 square that was supposedly left over. The books balance to the last penny. In a finite world, area and volume are preserved exactly. Banach Tarski is not this kind of sleight of hand. The 2 balls it finishes with are not off by a hair. The price is paid somewhere else entirely. Those pieces are a mist of dust points, scattered beyond anything you can picture. And the road to that destination begins, of all places, at a hotel. A hotel with room 1, room 2, room 3 going on without end. This is the one Hilbert is said to have used as an example. Tonight the hotel is full. There is not a single empty room, and then one more guest arrives. The manager solves it with a single announcement. Would all guests please move 1 room over? An infinite hotel has no last room, so not a single guest gets pushed out onto the street. And room 1 is now empty. The hotel was full, and yet 1 more guest got in. This bewilderment has a long pedigree. Back in 1638, Galileo paired up the natural numbers with the square numbers. The squares are only a part of the natural numbers, yet every single one finds a partner, with nothing left over. The part matches the whole. Now let's build the hotel on a circle. Instead of an announcement, a single rotation. The rim of a circle is packed solid with points. Pluck 1 point out with tweezers and a hole opens up. Can we fill that hole just by rotating the points that are left? Bringing in a new point is cheating. All we can do is slide them around so it looks impossible. And yet it works. Call the spot where the hole is angle 0. Follow the rim a distance equal to the radius, and the angle you have swept is 1 radian. From there we plant a flag at every spot 1 radian further along. The first flag lands at angle 1. Around the 7th flag we pass a full turn, and after that they keep going round and round endlessly. Here is the decisive fact. For a flag to ever come back around onto an earlier one, a full turn would have to be a ratio of whole numbers, and that number is irrational. So the flags never overlap ever. Now the announcement goes out. Would every flag please move 1 radian clockwise? This is less an announcement than a plain rotation. We grab the whole crowd of flags at once and turn it. Watch. The first flag lands exactly on the hole. The second flag moves into the first one's spot, the third into the second's. There is no last number, so whatever spot opens up, the next flag fills it. Without adding a single point, 1 rotation made the hole disappear. Turn it the other way and you can make a point vanish instead. We will use this trick again in the final assembly. Now for the dictionary. Let's visit the bizarre dictionary that Ian Stewart imagined. It is called the Hyperwebster. It lists every finite string you can build from the 26 letters of the alphabet. Meaningful or not, even the gibberish that will never mean anything is in there, without exception. A single volume would be infinitely thick, so we split it into 26 volumes. Then an editor comes up with a way to save ink. Erase the leading A inside the book. So they erased it. AA becomes A and AB becomes B. The editor opens the printed Volume 1 and freezes. Volume 1 had become the entire dictionary. Of course it did. Every string that can follow an A is simply every string there is. Apart from one scrap, the empty word left behind when that single A was erased, it is the complete dictionary. The same thing happens in all 26 volumes. And all they did was save ink. It is a legal piece of infinity magic. Exactly like shifting every guest one room over in Hilbert's hotel. The blueprint comes into view. Split a ball into volumes, erase the first letter, and one ball becomes several. Only a ball has no letters on it. The move that plays the part of the eraser is rotation. Now close the paper dictionary and take the ball in both hands. Let us write a dictionary with nothing but rotations. We will use exactly 4 moves. 1 turn to the right, to the left, up and down. The angle of a single turn cannot be just anything. It is the angle whose cosine is 1/3, about 70.53 degrees. String these moves together and you get a word. 1 rule. Each new move is written at the front. So URRD is the recipe for turning down, then right again, and finally up. But we never write a letter that immediately undoes the one before it. An L right after an R means nothing happened at all. Collect them that way and, with only 4 letters, you get an infinite dictionary just like the Hyperwebster. The 4 moves are, in the end, just 4 rotation matrices in 3 dimensions. In code they look like this. This tree is the map of that dictionary. The white dot in the middle is the capital, where no move has been made at all. The first letter splits them into 4 countries. Count only the words of length 6 or less and you already have 1457 of them. Now we replay the Hyperwebster. Pick up the words of the left country and erase the leading L. What remains is everything except the word starting with R. 3 whole countries and the capital comes along too. Because an R, which would undo it, can never follow an L. 1/4 of the tree has swollen up all at once. Let us balance the books. Swell the left country, add the right country, and you have the entire tree. Do it once more with up and down and you get a second entire tree. The leftover capital is handled by hole filling. The first letter is the most recent move. Erasing a leading L is nothing but grabbing the whole piece and turning it by R. Why that angle of all angles? Turn by 90 degrees each time and a word that repeats R 4 times lands right back where it started. That angle is proven to allow no such coincidence, ever. Rotations like these are called free. Hearing it all in words alone feels like being conned. This time let us swell it with our own hands. Here is the entire tree of rotation words. The white dot in the middle is the capital and there are 4 countries. Now we keep only the left country. The words that start with L, about 1/4 of the tree. We erase the leading L. On the ball, that means grabbing this piece whole and turning it once to the right. Add back the right country we set aside and the shape of the whole tree is complete. Do it once more with up and down and you have 2 trees. The number of points never changed and every step was 1 turn of the whole piece. Every ingredient is ready. All that remains is to move this tree onto the surface of a real ball. The method is stamping. Apply every word in the dictionary to a single point. And that swarm of points is the starting points constellation. Thanks to the magic angle, different words always stamp different points. Now keep only the points of the left country. All 364 of them are scattered over the entire ball. Look at the check as well. We grabbed these points whole and turned them once to the right, and they landed on the points of the words that do not start with R, matching down to the last decimal place. One constellation is not enough to cover the surface of the ball. There are uncountably many such constellations. So here comes the final move. From every constellation we pick one representative point and make a list. And then almost every point on the sphere gets one single address. Split the sphere into 4 piles by the first letter of the address, then give the left pile 1 turn to the right. It swells into everything except the right pile, and adding the right pile back gives the whole surface. Do it once more with up and down and you have 2 surfaces, and hanging a needle from each point down to the center gives you solid balls. With 5 pieces, 1 ball becomes 2 balls. And it has even been proven that 4 pieces are impossible. And what guarantees that quiet little step, picking the representatives, is exactly the axiom of choice. This axiom only says that you can choose. It never tells you how to choose. So the 5 pieces are only proven to exist. A recipe for actually building them will never exist. Now let us go back to our first suspicion. Where on earth did the volume come from? If the original ball was 1 liter, the 2 finished balls come to 2 liters together. Cross those 5 pieces, the books ended up like this. And yet rotating and moving can never change volume. The answer is devastating. Those pieces have no volume. Not 0, it means any value you assign leads to a contradiction. Suppose you could assign a volume to the pieces. The books end immediately in this contradiction. Those pieces are a mist of dust points shaped by the axiom of choice, non-measurable sets. Vitali first showed they exist in 1905. The law of volume conservation was never broken. It is a law among things that have volume. While taken apart, the pieces travel outside the world of volume. By the time they are balls again, there are already 2 footnotes. On the line and in the plane, this kind of duplication has been proven impossible. From 3 dimensions on, rotations tangle richly enough. And a real orange is finitely many atoms, so it is safe. In the world Solovay built in 1970, this paradox does not exist. It is not a lie, it is the bill. Shall we boil the whole road we traveled down to a single line? In the infinite, a part matches the whole, and this paradox is that match built out of letters and rotations. No new volume was created. Pieces whose volume cannot be spoken of simply took a trip outside the books. It all started in 1914 with the paradox Hausdorff found on the surface of a sphere. In 1924, Banach and Tarski completed it with the solid ball, and then went one better. In 1990, Laskevich cut a disk apart and made a square of the same area. The pieces needed about 10 to the 50th power. A paradox is not a siren wailing that mathematics is broken. It is the sign at the border where intuition's jurisdiction ends. Volume is conserved. The whole is greater than the part. Beyond the border, both go back through inspection. So there is no need to expect your orange to become 2 tonight. Mathematics walks honestly all the way past where intuition reaches, and now and then it comes back carrying a view you can hardly believe. If you enjoyed today's video, please subscribe, hit like, and turn on notifications. See you in the next story.